To comply with various government regulations, organizations keep their information protected by ensuring that an individual is only allowed access to the subset of the information that is needed to perform their job tasks. For information stored in relational databases, the ability to control data access at the row and column levels are required. Traditionally, this is implemented using views, security mechanisms, or in the application logic. Unfortunately, this approach only enforces the policy when data is accessed through an application or view. In other words, it is not a pervasive solution, nor is it data-centric or even applicable in some areas. Moreover, it does not protect against access by privileged users such as those with data access authority, and therefore does not help in achieving compliance with the above regulations. DB2 introduces the concept of row and column access control, or RCAC for short, as an additional layer of security that can be used to complement the table privileges model, and enables DB2 to take part in an organization's efforts to comply with government regulations. RCAC can also be used to control access to a table at the row level, column level, or both. The access controls are set up in a way that is transparent to existing applications. No application changes are required to take advantage of RCAC. With the row and column access control, no database user is inherently exempt from the RCAC rules, not even higher-level authorities. In fact, the ability to manage RCAC within a database is vested solely in the security administrator. Thus, customers can rely on RCAC to ensure that users can access data on a need-to-know basis. Another key advantage of the RCAC solution is that it ensures that table data is protected regardless of how that table is accessed via SQL. This includes through an application, through ad hoc query tools, through report generation tools, or database objects. Thus, RCAC sits perfectly in the overall database security framework. Consider the healthcare insurance industry model. Healthcare companies follow this model to comply with the Health Insurance Portability and Accountability Act. Medical information and the personal information of patients are transmitted across these organizations. Hence, all the organizations involved must ensure the safety of the healthcare data. The guidelines are: ensure privacy of protected health information, protect confidentiality of electronically transmitted data, control data access to privileged users only, and log access of protected data. We use an example of a healthcare company with these users. Each of them has a different need in terms of what type or level of data they need to access. Some users are involved in managing the database, while others access the database to get healthcare information. The scenario is demonstrated using the Technology Explorer. Alex, who is the security administrator, was asked to restrict row views on a need-to-know only basis. Here, he created a row permission on the patient table. The patient is allowed to view his own data, and the physician is only allowed to view the data of all his patients. Users who are in the accounting, drug research, or membership office can also access all patient data and make sure the row permission applies to all references of the table. To enforce the row permission with the above rules, you simply need to activate the row access control. Assume Sam is Dr. Lee's patient but Doug is not. With the row permission the security administrator just implemented, Dr. Lee can view and update Sam's record. On the other hand, Doug's record is not visible to Dr. Lee at all. Row permission in RCAC suggests that anyone who cannot view the data cannot update it. At this point, data is protected based on who is connected to query the data. For example, John as an accountant can view all patients' information. Dr. Lee views his patient information, and Peter, although he is the database administrator, doesn't need to view any patient information and therefore cannot. Bob as a patient can only view his information. By implementing row permission, users in each role are restricted to viewing data that he or she is privileged to access. Similarly, Alex creates a column mask to hide the account balance of the patients to be viewed only by people with an accounting role. A column mask here makes sure that anyone who queries the patient information will see an account balance of 0 if the user is not in the accounting role. When Dr. Lee connects to the application to fetch patient data, he sees his patient information, but the account balance information are zeroed. Here we can see that both row permission and column masks are applied to the patient table. The social security number and the medical information of patients stored in the pharmacy column are also masked so that only the medical information of the patients who wish to disclose it are accessible. A drug researcher who uses the hospital application to fetch patient data from medical research views only a masked SSN and medical information of those patients who have accepted to disclose their medical information. Thus, data is protected at the table level, irrespective of the application used to access it. As introduced earlier, any database objects like view, UDF, or trigger, which access RCAC protected data, will be enforced the same authority depending on the users running the objects to get the RCAC protected data. By creating secure database objects, they coexist with RCAC without data leaks or compromising performance. The database administrator Peter creates a view to see which patients have opted to disclose patient information. The users are given permission to use the view. Dr. Lee queries patient information using the view, and the view only returns his patient information. Thus the RCAC row permission doesn't change, although data was fetched using a view. In this way, database objects do not become a backdoor. In summary, the row and column access control is very beneficial to applications where regulatory compliance is critical, to applications where there is data hosting and data consolidation, and to multi-tenancy applications. This DB2 solution helps provide better overall performance and security, since application servers no longer need to handle the security rules. They can now be handled by the DB2 server.